Hello everyone, in today's video we are going to discuss a current affair topic which is related with geography, tsunami. You all must have recently read articles regarding tsunami wreaking havoc over Indonesia. In today's video we will discuss the concepts regarding tsunami, the characteristic features of tsunami, the causes of tsunami, and also we will solve some of the model questions related with tsunami which was asked by UPSC for other exams like CDS and NDA. Anyway, let's get on with our concept. So first of all, let's see what is tsunami. Now tsunami is a very powerful high energetic waves which we can find in ocean that we call it as tsunami, right? They are very high energy waves out in the ocean, and there are various characteristic features of tsunami which we need to clearly understand, right? So first of all, the tsunami waves move unnoticed in deep sea. Just imagine this. This tsunami waves which are having say around 30 meters of height, which wreak havoc over coastal regions, they are unnoticeable in deep oceans. So imagine this, if you are in a boat traveling in a deep ocean and tsunami waves happen to travel beneath you, you won't even notice it because it's unnoticeable in deep sea. And about say around 12 inches, that's right, the sea level will rise only about 12 inches while it is at deep sea. And this same tsunami wave, when it is reaching the shallow waters of the coastal region, the waves will rise up to even 30 meters. Okay, so that's a very huge point that you have to remember regarding tsunami, right? It's the wave height or the tsunami can grow in height when they are reaching shallower water, and in deep sea they will be unnoticeable. Now imagine this, if we need to predict tsunami waves or if we need to track the movement of tsunami waves from satellites, if you are observing tsunami waves, we won't be able to detect the movement of tsunami waves. For the reason being, tsunami waves are unnoticed, or they travel unnoticed in deep sea because their height will only grow higher while they are at the shallower sea, right? And the third point, as the waves travel inland, they build up to higher height as the depth of the ocean decreases. We'll see in detail how this process is taking place. For now, just remember that the tsunami waves are unnoticeable in the deep sea and they will be growing in height as they are approaching the shallower water. And the next one, an approaching tsunami is sometimes preceded by a noticeable fall or rise in the water, right? So before a tsunami, coming towards a coastal region, the seawater will be pulled, it will be falling, or sometimes the seawater will increase. The level of the seawater will increase, right? So this you have to remember, noticeable fall or rise in water. Sometimes the water will retrieve, exposing the entire seabed, and what happens is that if people are not aware about this, everyone will go to the shore and look at this exposed seabed. Then only after a few minutes, the large waves will strike them, right? So a symptom, or we can identify a coastal region which is going to be struck by tsunami. The sea level will either abruptly increase or it will fall down, right? In 2004, the Sumatra tsunami, which even affected the India's eastern as well as western coast, the sea level, we found that the sea level was retreating. We found a fall in the seawater, right? So this is a symptom with which we can identify tsunami waves. Now the speed of the tsunami waves depends on the ocean's depth rather than the distance from the source of the wave. This is almost related with the feature which I told you regarding the height of the tsunami waves. The tsunami waves will be traveling with higher speed in the deep ocean, right? They can travel as much as, with velocity as much as that from say jet aircraft at say 700 or 900 km per hour. But when they are reaching towards the coastal region, the shallower water, their velocity will decrease. Again, as we proceed in this video, we will see how this process is taking place. So these are the certain characteristics of tsunami that you need to keep in mind, right? They are high energy waves in the deep ocean. And when I'm saying high energy waves, there is this technical term regarding the energy of waves. You have to remember that a wave, its energy is dependent on two factors. One, the wavelength or the wave height. Wavelength means the adjacent distance between crest or trough, or the wave height means from the mean level what is the height of the wave. So these are inversely proportional. Suppose if a wave is having high energy, the wavelength will be very long, right? In that case, the wave height will be less, right? But if sometimes a wave height is very high, then the wavelength will be less, right? This is a bit related with physics, and as I said earlier, as we proceed in the video, we'll see how this process is taking place. And next, let's look at what are the main causes of tsunami. This is a probable future question for your prelims, right? It can be asked like tsunami waves are not caused by which of the following factors, or they are caused by which of the following factors. Now recently this the reason behind this same video itself is the tsunami which affected Indonesia, and one odd event which we found was a volcano was able to create a tsunami. Normally when we see tsunami news, it will be associated with an undersea earthquake, right, all the time. So for example, say 2004 tsunami which affected India, the Sumatra tsunami, right? So that was because of an earthquake happened in the Sumatra island in Indonesia. So that again was because of an earthquake. So this one, like tsunami affected or was caused because of volcano, and for that same reason it can be asked regarding the causes of tsunami, right? So and the main causes of tsunami, they are undersea earthquake, volcanic eruptions, landslides and meteorite. Now we'll see how an undersea earthquake is able to create a tsunami. Now first of all, you have to understand that an earthquake means release of energy, right? Release of large amount of energy, and because of this release of energy, there can be movement in the oceanic floor or be it in the continental floor. Since here we are talking about the undersea earthquake, right? Due to release of this energy, due to earthquake, the oceanic floor will start to move. Now imagine as in this picture, right? As you can see here, the brown colored region, they are the oceanic crustal region, right? And on top of this, we are having large amount of ocean water. Now imagine this, due to the release of energy or due to the earthquake, the land moved, right? And one part of the land is sliding above the other part of the land. So what happens is that all the water lying on top of this crustal region will all of a sudden will be uplifted. They will be moving upward. Now imagine this, in an ocean at certain region, water is moving upward. Now think about this, can oceanic water stay like this, right? Can it can it be elevated like this? No, probably, right? We all must be knowing water will always try to attain a same level, right? So what happens is then, after this earthquake, after the vertical column of the oceanic water is being disturbed, the large amount of water is moving upward, and this water will start to come down, right? And this coming down movement will create the high energy waves, which we call it as tsunami waves, and they will be traveling in all directions and they will be traveling towards the coastal areas. So an undersea earthquake is resulting in a tsunami because it is disturbing the vertical column of the oceanic water. Now statements like all earthquakes can cause tsunami, which is actually wrong. An earthquake in a continental region won't be causing a tsunami. Now all undersea earthquakes can cause a tsunami. Even that could be wrong, right? Because certain earthquakes will be there where the crustal regions are not moving upward. They are simply moving parallel to each other, right? If you have studied geomorphology, you'll understand that there are various plate boundaries like, the convergent boundary, divergent boundary, and transform boundary, right? In this case, if you are considering say transform boundary where the plates are moving parallel to each other, the crustal region is not moving up. In that case, a tsunami won't be caused. So a particular earthquake which is able to move the crustal region upward, which can disturb the vertical column of oceanic water, only such earthquake will be able to cause tsunami. Now next, let's see how how volcanic eruptions can cause tsunami. And before going to that, this is another picture showing an earthquake causing tsunami, right? Here wherever we are having the subduction zone where the plates are converging and when the plates are going under another plate, here in this zone we will be having large frequent earthquakes taking place, and due to this frequency of earthquake we will be having tsunami waves being created. As you can see in this picture, initially where the tsunami waves are created, their wavelength is very high, they are very stretched. But as soon as they are approaching the shallow waters of the coastal region, what happens is that they will grow in height, right? It can grow as much as even more than 30 meters. And next let's see how a volcano is causing how is this volcanic eruption causing tsunami, as in the case the recent tsunami in Indonesia, which was due to the volcanic eruption in Anak Krakatau volcano, right? So volcano can influence tsunami generation in two ways, right? In this picture, it's actually a volcano is actually outside or in the exterior regions of the ocean. So in this case, if an explosive volcanic eruption is there, the dust particles or the debris, right, the large chunk pieces of landmass can fall into the ocean, resulting in landslide. So this landslide is actually triggered because of the volcanic eruption. And this movement, this sliding movement of all the large chunk of piece of land mass into the ocean can disturb the water column, resulting in tsunami waves, right? So this is one way in which volcano can cause tsunami waves, by resulting in the movement of, by inducing a landslide. Volcanic eruptions inducing a landslide which can result in tsunami waves. So these materials, right, these materials which are falling into the oceans, we usually call it by the name pyroclastic material, which will be flying off because of the explosive eruptions of volcanoes. Now, in this picture, you can see that another submerged volcano. The earlier picture, the volcano was outside the mean sea level, right? And this picture, the volcano stopped. The vent part of the volcano is submerged. Now here imagine this, if a powerful volcanic eruption is taking place, the magma will be pushing upward, right, with all its pressure. And that also can disturb the vertical water column. And that can also result in tsunami, right? So an undersea volcano or simply a volcanic eruption can also result in tsunami, right? In two ways. One, the volcanic eruption can result in large pieces of landmass falling into the ocean. And in second case, that the push of the magma, the eruption, the volcanic eruption itself can result in tsunami waves. The submerged volcano erupting itself can create tsunami waves. Now, these are the various causes, the main important causes of tsunami. They are earthquake, volcanic eruptions, as well as landslides, and fourth one that you should remember, meteorite. Right, meteorite means they are the the exterior objects that are coming towards our atmosphere, which are probably if they are colliding in oceans, it can disturb the oceanic column or the water column, resulting in tsunami. But as of now, in our recorded history, we are not having any such events. But as the 3D climate and 3D weather model shows, right? The supercomputer model shows, if you are having a meteorite collision in the oceans, there is a chance for tsunami. But as I said earlier, in our recorded history, there is no case of meteorite resulting in tsunami. So if among the options, if there are meteorite is there, right, meteorite can cause tsunami, right, as well as the case of earthquake, volcanoes, landslides, all these events can cause tsunami. The next one, right, let's talk about one of the typical features of tsunami, which is called as Schweyaling effect. Now this effect, as you have seen earlier, right, whenever the tsunami is moving in a deep sea, it will be having unnoticeable. Unnoticeable means the wavelength of the tsunami waves, they are much high, right? Now this term, right, the technical term, the wavelength means that any energy wave will be transferring in the form of wave, be it the sound or be it the light or be it the water ripples, right? So wavelength means the distance between adjacent crest and trough, we call it as wavelength. Now if a wave is having long wavelength, right, it means that the wave's height will be very less. As you can see in this picture, in deep water, the wavelength is very high, right? So that means their wave height will be less, because you have to remember that the waves are being generated because of the energy transfer, right? And the wavelength and wave height both can influence energy of a wave. If wave height is higher, the wavelength will be longer, and if the wavelength is very less, means that the wave height will be very high, right? So as you can see in this picture, in deep water, the tsunami waves will be having very long wavelength, and their wavelength can reach as much as say 100 kilometers. So one wave will be having 100 kilometers of length. Now imagine this, the wavelength of light or wavelength of an electromagnetic radiation, they are in terms of nanometers, right? At the same time, a tsunami can have a wavelength of an 100 kilometer long wavelength, right? So their height will be very less. So in deep sea, the tsunami waves will pass through or will travel unnoticeably, right? Now, when this long wavelength waves, when they're reaching towards a coastal region, what happens is that, imagine this, first set of wave is reaching the shallow region, right? As the depth of the ocean is decreasing, their wavelength will start to decrease, or their velocity will decrease and their wavelength will start to decrease. And as I said earlier, in order to conserve the energy, if the wavelength is decreasing, the height will start to increase. So what happens is that since each wave is striking this shallower coastal region, right, their wavelength will start to reduce. In order to conserve the energy, their height will increase. So a tsunami wave which is having say around 12 inches of height in a deep sea will grow in their height like to up to like certain up to say even 30 meters when they are approaching a shallow region. So this effect, the technical term we call it as Schuyling effect. And now in perspective of your exam, you have to remember that the tsunami waves will grow in height as they are approaching shallow oceanic water, right? Same way, the tsunamis velocity will be very high in deep sea and velocity will be decreasing as it is approaching shallower region. Then another point you have to remember from this slide is the case of wavelength. Tsunamis are having very long wavelength in deep sea and their wavelength will start to decrease as they are approaching the shallower oceans. The next due to this tsunami waves affecting the Indonesian region, this topic is important as I said earlier, the topic the tsunami itself. Now from this again you can expect a map based question or another topic why Indonesia is prone to earthquake, tsunamis or volcanic eruptions, right? I mean another topic is related with this which is called as ring of fire. So this ring of fire region as it is shown in this red colored region or marked in red colored in this picture, like this region is having large amount of volcanic eruptions, earthquakes as well as tsunamis. The reason is that this marked region is having a convergent plate boundary. Convergent plate boundary means where the two plates are coming together, converging. And this region, due to the energy release and due to the subduction, can result in volcanic eruptions, earthquakes as well as tsunamis and large number of landslides. And if you look at the physical map, you will also be able to find along this convergent zone, we are having various trenches in the oceanic floor. All of these things, they are related together. Same way, we are having fault mountains along these ring of fire region. We are having fault mountains. All of these relief features like fault mountains, like the trenches, all of these things, they are related with the convergent plate boundary, right? So Indonesia happens to lie in this convergent zone, right? Where various plates are there, like say Pacific plate, Philippine plate, you can say the Indo-Australian plate. This is a zone where that convergence is taking place, and due to that convergence zone, we are having large number of earthquakes and volcanoes taking place here, and further, this is in turn resulting in the tsunamis, right? So you can expect a statement like why Indonesia is more prone to tsunamis, right? One reason is because of the plate boundary and large frequency of earthquake as well as volcanic eruptions. And next one, from this topic, a map-based question, you can expect a map-based question, right? As you must have, if you have analyzed the previous questions, you'll understand that in recent years, UPSC is giving more importance to map-based questions, and especially those places which are in news, right? There's a tendency that they will be asking more questions from that selected topic. In the previous prelims, there are as much as 7 questions coming from the location or map-based question. There were 7 questions. So in that perspective, right, you can expect a question from either regarding this volcano, which volcano resulted in these tsunamis, right? It was Anak Krakatau volcano, right? And you have to remember that where it is located. It is located in Sunda Strait. So this strait is actually important for this year's prelims, right? Sunda Strait is interlinking Indian Ocean as well as Java Sea, as you can see in this picture, right? Towards the west of Sunda Strait, we are having Indian Ocean, and towards the east of that or northeast of that, we are having the Java Sea. So Sunda Strait is connecting Java Sea and the Indian Ocean. And next we have to remember that the Sunda Strait is between which all islands? The Sunda Strait is between 2 islands which are Java and Sumatra, right? The main 2 islands in the Indonesia. So on map level question, you can expect questions related with the Sunda Strait, where it is connecting, or the islands in between, the Sunda Strait is connecting which all islands or something like that, right? And the name of this volcano is Anak Krakatau, and it is in Sunda Strait in Indonesia. Now next, let's solve some of the model questions. As I said in the the starting of this video, this model question was asked by UPSC in one of the CDS or ND exams, right? So you can expect same level question for our UPSC prelims, the 2019 prelims. Which one among the following is not correct regarding tsunami? So as I said, the various characteristic features of tsunami has been given here, and we have to find out which one is incorrect regarding the tsunamis. The first one, tsunamis have a very long wavelength, which is actually true in case of if you are considering tsunami in deep sea. And in this statement, they are not specifying whether it's shallow water or deep sea, and we can assume the deep sea, and in that sense, like the statement can come true, right? Tsunamis have a very long wavelength, which is true. The next one, tsunamis have a slight swell of about 12 inches above the normal sea surface, which is again true. We have seen earlier in deep sea, the tsunami's wave height will be very less and it will be unnoticeable, right? So that thickness will come as much as 12 inches. The third statement, tsunamis grow in height when they reach the shallow water, which is again true, because in order to conserve water, when they are reaching the shallow water, the wavelength will decrease and the wave height will increase. So the tsunamis grow in height when they reach the shallow water, which is again true. Now the fourth option, tides also play an important role in the generation of tsunami. Now here the answer comes out as option D, because like the tides, they are not playing any role in the generation of tsunami. We have seen earlier, a tsunami is generated when the vertical water column is disturbed, either due to earthquake, volcano or landslide. A tide is not having any role in the generation of tsunami, right? Often, like initially when tsunamis were in news and all, right, we were used to confuse it with tidal waves. So even in some websites still, the tsunamis are considered as tidal waves, which is absolutely wrong. Right? Tsunamis, they are not tidal waves, right? They are created specifically when the vertical water column is being disturbed, right? And an event like tide, which is influencing or which is taking place in the top portion of the ocean, cannot influence tsunami in any way, right? Now the only influence, the only way in which you can say tide and tsunami is related, if you are having say high tide, large amount of oceanic water will be available at that place and the strength of the tsunami will somewhat be higher. And if you are having a low tide, the strength of the tsunami will be somewhat lesser, right? But you cannot say tsunami is playing an important role in the generation of, the tides are playing an important role in tsunami. You cannot say like that, right? So here, since the question is not correct, like here the answer comes out as D, tides are not playing an important role in the generation of tsunami. Okay. And the next question, another model question as I said earlier, which was asked by UPSC in some other exam. Tsunamis are not caused by, right? Again, an ABCD question, hurricanes, earthquake, undersea landslide, volcanic eruptions. Here the answer comes out as hurricanes. Because again, hurricanes means they're tropical cyclones which are influenced, means their spinning movement of wind which is taking place on top of the oceans, and it cannot it can in no way create the tsunamis. Only events which can disturb the vertical water column will be able to create tsunamis. So here answer comes out as A. So since tsunami is in news, or the general tendency is that whenever any weather event or any physical event which is in news, UPSC tends to ask more questions or a question regarding that for your prelims, right? You can say that is a current affair related topic, and the chances are higher when that current affair is related with your convention syllabus. And tsunami is in our syllabus, and say in 2017 mains examination, UPSC asked asked a mains question in GS3 from tsunami, and for that perspective also you can expect questions being asked for your prelims from tsunami.